All right, so here's your homework on reviewing, graphing any of the six, any transformation. So sine has an amplitude, and it's the number being multiplied in front as a positive number. The period would be 2 pi, but inside we need to undo it, divided by 2, so our period is pi. Sine starts in the middle, so I need to find the middle, which is 0. Then I need to find the end of the period. That's the end of the cycle. Exactly in the middle also is the midline. So sine starts with middle. Then in between the middles, the first middle goes up to 4. Then the next middle goes down to -4, and you have your pattern. So we're going to just continue that pattern to the right, to the left. And then once I have it, I make sure that it's a wave, not like corners, not V's, but like U's, or if you want to think of that. And I draw my wave. It's therapeutic once you do this, I think. Done. Next one, tangent, no amplitude. But the period would be pi, and there's nothing inside that would change that. So that's it. Tangent starts with a point of inflection. And then at pi would also be a point of inflection. In between them is an asymptote. And there's my pattern. So count the squares if you like, but know the pattern. I'll show that many in the cycles. The next thing I need to worry about is this negative in front. So normally, in between the first two, you go to +1, but times negative makes it -1. And normally it would be negative, but a negative times a negative. That negative changes the direction of it. So we're going to go down to the right and up to the left. And we're going to follow that pattern to the right and left. Done. Number 3. Cosine has an amplitude. Positive, so 1.5. The period is 2 pi, but we divided it by 4. So this is going to go up and down really quick. Pi over 2. So cosine starts either at the top or bottom. So since it's negative, it starts at the bottom at -1.5. At pi over 2 will be the end of it. So in the middle would go to +1.5. And then in between those would be my midline. So you can see how it's going to go up and down really quick. So let's just fill out 2 boxes, 2 boxes, 2 boxes, 2 boxes, 2 boxes, 2 boxes, 2 boxes. Here is same thing. 2 boxes to the right, 2 boxes to the left. Then in between it's here. I'm not even going to fill it. So it's so tiny, I'm just going to connect the upper and lower. And the midline will take care of itself as I go through it. Again, kind of therapeutic. Up and down. Here we go. Amplitude. No amplitude. Period would be pi. Times, to undo it, the fraction is 3 pi over 2. Cotangent starts with an asymptote. And at 3 pi over 2, it ends. In the middle between them is a point of inflection. There it is. Now, 3 changes it. So the first 2 in the middle would go to +3 or +1, but times 3 means that it's now going to +3, and in the middle will go to -3. And then it curves down to the right and up to the left. Oops. In the middle. So it's like over here. In the middle, it's like here. It's in the middle of the boxes. And you did it. All right, number 5. Amplitude, none. Period would be 2 pi times the reciprocal. So 6 over 4 is 3 pi over 2. Secant starts with an upper or lower vertex, so at 2.5, And then at 3 pi over 2 will be 2.5. And in the middle would be the lower vertex. So in the middle between these would be negative 2.5. In the middle between those, it'll be between the boxes. Are your asymptotes. Then it just alternates. And the upper ones fold up and the lower ones fold down. Done. Number 6, there's an amplitude, it's 2. The period would be 2 pi, but to undo 1/2 times 2, so now the period's 4 pi. Cosine starts at the top or bottom, so that 2 tells me it starts at the top. At 4 pi I can't get to, so half of 4 pi is 2 pi, so that's going to be at the bottom. And then in the middle is the midline. And there's your pattern. Done. Number 7. The amplitude here is 4. The period is 2 pi, and it doesn't change. There's nothing multiplying here. But the phase shift's negative pi. That's where we're going to start. And no vertical shift, and it's 0. So cosine starts at the top at positive 4. So at negative pi, we go to 4. Then I apply the period. So add 2 pi to the right, and there's the end of the cycle. Exactly in the middle would be the bottom of the wave at negative 4. And then in the middle of that is going to be the midline. And then that's the pattern. Pattern power. Done. Number 8. Secant doesn't have an amplitude. Period is 2 pi, and nothing changes that. There's a shift to the right. Pi over 4 is where we start. There's a vertical shift of 1. So it's wise to think of my upper vertex and my lower. So the upper would have been 3, but I'm going to add 1. The lower would have been negative 3, but I'm going to add 1. So these are the numbers I go to, the y coordinates when it's the vertices. Secant starts with an upper vertex when it's positive. So we're going to start at 4. So at pi over 4, we go to 4. Then I'm going to go 2 pi to the right. And again, it's going to be 4. And then in the middle between them is going to be negative 2. In between those are asymptotes. All right. Then the upper ones fold up and the lower ones fold down. All right, number 9. No amplitude. The period would be pi, but we're going to divide by 2. The phase shift's negative pi over 4. That's where we're going to start. No vertical shift. And that 2 will stretch it out. We'll get there when we get there. So there's that. So 0 is where the point of inflection is. So cotangent starts with an asymptote. So at negative pi over 4 is an asymptote. Then our period is pi over 2, which is 2 boxes to the right. And then every 2 boxes is an asymptote. That's enough for me. Then, in between, it's not going to oscillate, same picture all the way across. We have zeros in the middle, and then cotangent. So with the first two, again, we're starting at pi over 2. Right? No, sorry, starting at negative pi over 4. I got confused there for a second. So at negative pi over 4, in the first point, in the middle there, it's going to go up to 2. And in the middle there, it's going to go down to negative 2. And that's going to give me my picture. So to 2, and then down through negative 2. All right, number 10. Tangent has no amplitude. The period would be pi. To undo 1/2 is times 2, so the full period's 2 pi. The phase shift's positive 3 pi over 4. No vertical shift, so the midline is at 0. That's the point of inflection. So we start at the phase shift, 3 pi over 4, and it's a point of inflection at 0. Then I apply 2 pi for the period, which is 8 boxes to the right. So I can't do it to the right, but I can go 8 boxes to the left. That's 3, and 5 is there. So there are my 2 point of inflections exactly in the middle. So if I count 4 boxes to the left is an asymptote. 4 boxes to the right. My eyes sometimes get all flippy on me. Then, in the middle of that, so 2 boxes to the right, I'm going to go the first, where do we start? 3 pi over 4 in here. It goes to the upper, goes up to the right. So it goes up to 4. And then in the middle here it goes down to negative 4. So there it is. So 2 up to 4, 2 down to 4, and then you have it. All right, last one, number 11. Sine. Look at all these fractions. So beautiful. Sine does have an amplitude, 2.5. The period would be 2 pi, but times the reciprocal, and cross out the 2's, you have 3 pi. That's the phase shift is where I'm starting, negative pi over 2. And we have a shift down 1. All right, so let's start. Sine starts in the middle. So at negative pi over 2, we're going to start in the middle. And our middle is at negative 1. That's the middle. Then we're going to go 3 pi to the right. Now 3 pi is 12 boxes, and I can't get there. If I did, it'd be like somewhere here to the right. So 6 boxes to the right is the middle. So 6 boxes to the right then is also the middle. Then in the middle between that, 3 boxes over, we're going to go to the top of our wave. And our amplitude is 2.5. So from here I'm going to go 1, 2.5. And then again 3 boxes over, 2.5 down. So 2 boxes over, or 3 boxes over, 2.5 down, 3 boxes over, back to the middle. And there it is. Pattern power. And done. Good job. I know it's not easy, but I know you can do it. Mr. G Math. Over and out.